So when AI works, it is absolutely more cost efficient than human labor. Originally, the models could only solve about 4% of those tasks. And the way we submitted our agent, solving 70% of the issues. An agent fails, and that engineer manually solves the problem. A vibe coder, good vibe coder, he will try to solve it with AI agent. The senior engineer will have the same level of AI capabilities, and the vibe coder will have much more advanced harness and tooling and prompts and whatever. He will actually be a better AI engineer, if you will.
I don't know about you, but I have almost zero idea how software engineering is going to unfold with agents. But I'm joined today by Andrew, founder of Zencoder, and formerly the founder of a multi-billion-dollar project management tool called Rike. Andrew helps us understand 1 or 2 steps ahead on where AI software engineering is heading, so we can hopefully build better DevTools.
We saw already one complete generational change, and there's one that's coming very soon. So almost like 2 generational changes in like 12-month period. And when those come, it's a good time to reflect and say, okay, like if I started today, how would I approach it? And then you didn't start today, right? You've been building towards it for the whole year. So from what I've been building, what makes me much stronger and helps me be the best and push harder, and what is no longer super relevant is new reality, and there's kind of a better way to reinvent this. And that goes to architecture, that goes to some protocols as well. As you know, for example, on the integration side, MCP, that was proposed by Anthropic and then picked up by other vendors like a wildfire. So that's right now is the de facto standard for integrating different tools into AI agents. It has many other things that it can do, but primarily where everybody's using it is bringing tools to agents. And so that became de facto standard. That's one protocol. Another protocol that looks very interesting right now is agent-to-agent protocol. As we're starting to see more agent interaction, kind of more like farms, or little armies of agents that collaborate, or teams, I should say, of agents that collaborate. So, or pipelines of agents, like workflows. So a lot of interesting things happening.
And that's just like a protocol for how they defined how they pass
how they can
information to
interact with each other, exchanging. Yeah. Correct. And so I feel summer is a great time to kind of reflect on those things and make sure that you're ready for the next sprint. So comes falls, as you know, everybody comes back from vacations, and like you got conference after conferences, launch after launch. So summer is a good time for reflection.
Yeah. And on reflection, you mentioned the generations of code agents, or I don't know what the right word for what would you call the category?
Right now, the more correct word becomes software engineering agents. It all started with coding agents, right? But right now they do much more than coding. So we're moving. One of the things that's happening is we're moving from coding agents to software engineering agents.
Okay, so for software engineering agents, can you tell us like the generations, like even the first generation, and like rough timeline, and then maybe like where it's going?
So the first generation that caught everybody's attention was AI code completion. And the market maker was GitHub Copilot. They were, by the way, they were not the first product. Some people know the prior solutions like Kite and whatnot, but most people never heard of them. So they're the poster child, the household name was GitHub Copilot, and it promised a lot of things. But their really sticky feature that developers liked and actually used was the code completion. And it's nice, it's helpful, but it's been somewhat controversial, and as usual, part of the controversy comes from kind of sensationalism on both sides. Like on one side, there were claims that code completion is going to make you like 30% more productive, which was not the case. And on the other side, there are also some sensationalism talking about like how the code is really bad and it's going to like ruin everything and whatever, right? So everybody was trying to make the name for themselves. The truth, as usual, was in between. Like it was really nice, and a lot of developers liked it, but it wasn't necessarily like a big game changer. So that was first generation, and that's kind of roughly when we started our company, and we looked at that the space, and we said we recently realized that we can do much better job at generating code for two reasons. So one is so basically the products back then were single shot LLM calls, so what you back then would call kind of thin LLM wrapper. And a lot of thought in the market was, how do you buy a bunch of GPUs and make models smarter? And like people were like trying to make everything out of models. Like how do we teach models to compile code and debug code and this and that? And so, but kind of by the model itself, like try to build this kind of a mega brain that's like AGI, super AGI, right? Like how do we build this mega brain thing that you just tell it to do something and it magically does it for you? And I saw a lot of challenges with that approach, and I thought that more efficient approach that gives you much more value, much quicker and more efficiently, was that to focus on what happens before LLM and after LLM. So before LLM is they're extremely sensitive to the context that you give them. And the context could be your prompt, the context could be, in case of repository, it could be the files that it needs to work on. It could be higher level context, like what's the architecture of that repository, what design patterns are being used and whatnot. So LLMs are extremely sensitive to that because they're stateless. So they know nothing about your specific problem, nothing about your repository. They only know what you give to them. And from that perspective, it reminds me the good old 50 First Date movies. I don't know if you remember that one.
I still think I've seen that.
The character had an amnesia, and so basically every single day was a brand new day for him, right? So for her, I should say. So we have the same thing here. Like every single time you ping an LM, they know nothing about you or your project or whatnot. Right?
Yeah.
So they're extremely sensitive to the context. That was one area where we made significant improvements, and then the other one is it doesn't have to be just the model itself. As humans, our brains did not evolve much over the last 20,000 years, but you'd probably agree that as culture and kind of the things that we can do evolved significantly, right? And it comes back to knowledge, culture, and tools. And tools are extremely important. And so I always thought that, hey, why would I try to teach LLM to be a compiler when I could teach it to use a compiler, right? Like, why would I try to make it like the calculator if I can teach it to use a calculator? And so tools are extremely important. And so one of the tools that we gave to LLMs was, even kind of in that first generation, was a tool to check the syntax of the code. So if LLM generates incorrect code, we can identify that, right? And then we're seeing the next super important point, which is then you can build the feedback loop, which is extremely important for any intelligent system. Like even if you personally just want to walk a straight line, super easy task. But if you try to close your eyes, it's not going to be as easy, right? So we always need that feedback loop, and that was part of it. And now, if you think about those things that I just described, like the right context, their feedback loop, the tools, that's what today we call agentic systems, right? And what we call agents. So that's kind of how we started on that first generation. And as we were, and we very quickly built product that was able to kind of generate code better than direct competitors. But as we then kind of try to commercialize that product, kind of build the actual solution that's nice and polished and great UX and works here and there and everywhere, Anthropic shipped Claude 3.5 in October of last year. And that was the first truly agentic model that could successfully use tools. And that could explore the engineering environment, could operate with bash commands and whatnot. So, and that was our game changer, and allowed us and our competitors and just the overall market to move to the second generation of products, which is today the dominant kind of AI use in coding today, which is you have capable agents that work inside of your development environment, right? So you're still in control. It's still kind of human in the loop, and I would not even say human in the loop. It's human in control. But you have very, very powerful agents, starting with coding agent and then rapidly kind of evolving into all sorts of other related agents. So for example, you could have a code review agent or this or that. So that's their category as it is today.
Scaling DevTools is sponsored by WorkOS. If things start going well, some of your customers are going to start asking for enterprise features. Things like audit trails, SSO, skim provisioning, role-based access control. These things are hard to build, and you could get stuck spending all your time doing that instead of actually making a great dev tool. That's why WorkOS exists. They help you with all of those enterprise features, and they're trusted by OpenAI, Vercel, and Perplexity. And if you use them for user management, you get your first million monthly active users for free. I honestly don't know any dev tools that have 1 million monthly active users, apart from GitHub maybe. So that'll get you pretty far. Here's what Kyle from Depot has to say about WorkOS.
We use WorkOS to effectively add all of the SSO and skim to Depot. It's single-handedly like one of the best developer experiences I've ever seen for what is like a super painful problem if you were to go and try to roll that yourself. So for us, we can effectively offer SSO and skim, and it's like 2 clicks of a button, and we don't ever have to think about it. It's like one of the best features that we can add to Depot. It's super affordable, which effectively allows us to like break the SSO tax joke and essentially say like you can have SSO and skim as like an add-on onto your monthly plan. Like it's no problem. So it really allows smaller startups to essentially offer like that enterprise feature without a huge engineering investment behind it. Like it's literally, we can just use a tool behind the scenes and our life is exponentially easier.
Yeah, actually, Andrew, sorry, just on a question on, maybe this is like has an obvious answer and is not interesting, but why was it that 3.5 was like the first one that could do tool calls? Like, do you have any understanding of like why, what it?
Well, all the stars pointed there. It was just the first to get there, right? The stars were pointing there. I think all the labs were working on more agentic models. I think a big part of the breakthrough, obviously Frontier Labs didn't stop disclosing what actually happens, right? So you can only guess, or you can kind of have maybe retrovision when open source gets similar results, right? You look at open source and you're like, oh, maybe the Frontier did the same thing. So I think there are two important things. So one is just accumulation of right data. As you know, there are companies like Scale and Surge that make billions of dollars right now on just generating the right data. So they're actual senior engineers that are working and generating what's called in the industry trajectories to teach those agents how to do different things. And so I think one, the natural trend of accumulation of the data, and that data getting more and more advanced, because as the labs kind of build the foundational data, then they focus on kind of generating the next level of data and the next level. So they accumulate more data, and more importantly, they accumulate the data at the higher and higher level that teaches the models to do more and more things. So that's one component. And the other component that's extremely important is reinforcement learning. And the labs, I think, started to figure out how to build the right kind of a training environment where the agent can attempt solving a real engineering problem multiple times, and then you know which solution is correct, and you can feed that information back into training. And then part of this, those things kind of look small and subtle, but they actually matter a lot. I think a big part of their reason why the industry progressed so fast in the last 12 months is one particular benchmark called SWE-bench, or in the industry called SWE-bench, SW standing for software engineering. And so prior to that benchmark, the models typically reported results on kind of Olympiad style coding, right? And that's not what happens in the real engineering. And for the bystander, it all looks the same. Like you got code here, you got code there, like it's all the same, potato. But it's not. Like if you're an engineer, if you work in there day to day, you know that there's a huge difference between you trying to build a large system that's used by millions of users versus you trying to come up with the more optimal way to sort an array, right? So those are very different tasks, and their training and knowledge of models from these tasks has very little transferability. There's some transferability kind of at the basic level. Think about it as you playing hockey versus you playing basketball, right? Or like there's some transferability of your athleticism, but at some point those are very different sports that require very different skills. And so originally the models kind of paid attention to those simpler coding tasks, and then at some point when they reached good results there, and when it became clear that that's not enough to solve real engineering problems, people came up with this benchmark, SWE-bench. And originally the models could only solve about 4% of those tasks. And in that benchmark, it had real world issues. They scraped real world open source repositories for documented issues. And they had the golden standard of solution to those issues. And not only that, but they also try to find their solutions that had unit tests. So you could test if their solution could be slightly different. You could still test if it works or doesn't work. So the build that benchmark originally had, I think, more than 2,000 tasks. I don't remember the exact number. And again, originally the models back at the day could only solve about 4%. But now, as you know, if you can measure something, you could improve it. So there was a target put in front of the frontier providers to improve, and they started building more data, and they started building better reinforcement learning setups to have models be capable of solving those issues. And there was rapid progress. And so for example, end of May, we submitted our agent that used a mixture model. The primary worker there was Claude 3.7 because 4 was not available yet. And we were #1 result on that SWE-bench benchmark. So
Really?
Solving 70% of the issues. And imagine that, like those are real world problems that we could solve 70% of those problems. That's very impressive. There's other similar benchmark. OpenAI scraped real freelancer jobs that got people paid. And so in that benchmark, it's kind of funny and interesting and catchy because you can measure your success not only in percentage, but in actual dollars. You could be like, hey, I solved for $70,000 out of $200 pool. And so that benchmark, again, at the time, we had the best results in beating everybody by 20% on solving kind of hard engineering problems from the benchmark. So
can you also measure if is it profitable to run it?
Yeah, that one is definitely profitable. Yeah. So when AI works, it is absolutely more cost efficient than human labor. Well, like I'm obviously proud user of our own product, but I also pay for other products. I have their top plan on Anthropic, and I use it all the time. I have a top plan on OpenAI, and the way I'm thinking it, the more I'm paying, the more I'm saving. It's not like I wouldn't like to pay them $20. I'm super happy to pay them $200 because then I can offload some tasks to them that would otherwise require me to have an executive assistant or somebody to find all this information and whatever. So that's to me, again, when it works, that's the caveat. When it works, then the more you use it, the better, and it correspondingly the more you use it, the more you pay for it, because those models are pretty expensive to on the compute side, right? So from that perspective, there's no free cheese. But again, my salary is much more than $200 a month, and so is yours and most people. So the saving is definitely there.
Yeah. And sorry, I interrupted you as you were just asking about profitability. But so sorry. So you were saying you were able to be #1 on SWE-bench, as well as to do really well on the one that's like presumably like Fiverr.
So Freelancer, and then and there are a couple of versions of SWE-bench. We're #1 in SWE-bench multimodal as well, which kind of measures your performance in multimodal tasks, because part of engineering is not just text, right? You try to implement solutions that, for example, replicate the wireframes that you're given or fixes some visual issue on the website. So that's exciting. And then we were I think rolling back, we were talking about kind of the generation of agents, right? So we started with code completion. We continued to kind of those coding agents in IDE, which are all the rage right now. People love them. Some people hate them, but I think most people like them.
So cursor,
cursor, yeah. And there are actually two different audiences, I'd say, for the agents, and both get the value from it, but the usage patterns and the value are quite different. So there's what we call in the industry vibe coders, right? So people who kind of build simple projects, typically prototypes. A lot of them are not engineers. They might still be technically inclined people and smart people, but not engineers, don't know how to code. And so they, again, create those simple apps from scratch. In the industry, it's called vibe coding. And that's fun. And most of the professional engineers occasionally do that as well for one reason or another. So for example, my kid wanted to build a mobile app, and I haven't touched mobile development in forever, and I just opened Android Studio, installed Zencoder in it, and then using Kotlin, which is a programming language that I never wrote in, created this mobile app for my kid, just to show him what you can do with kind of today's modern AI. Or our chief operating officer who runs go-to-market, right? He vibe coded an app for his friend who needed some simple e-commerce website. So that's one use case, pretty popular, and that's where today you can see that 10x from AI, where again, it's to some degree kind of infinite x, right? Because the person otherwise might not be able to create that app altogether. And then there's a very different setting of professional engineers. And they do not yet see that 10x. They already see good gains, but it's not yet 10x. And there's a variety of different reasons for that. So in professional setting, you typically have either one very large repository for your code that's called monorepo, right? So, and it's very hard, and usually it's gnarly, right? Like that monorepo has some tag depths. So I had like, I don't know if you've ever been to Silicon Valley. There's a building here called Winchester House that's very famous, and it was deliberately built by the owner to be very hard to navigate. They're like stairs going nowhere, or doors opening into the walls and whatever. So a lot of those monorepos, they have those components. So even your best engineers have hard time navigating them. And LLMs with their limited context definitely have trouble there. So that's one complication. Another very frequent complication is also instead of one super big repo, you could have like 200 smaller repos and a bunch of microservices. And again, it's all kind of spread over, and even for humans, very hard to grok, and for the models even harder. So you got those complexity, a lot of proprietary APIs that the models were not trained on. The models also don't have the choice of the library, because when people vibe code, they usually stick to some very modern and frequently used technologies. So it'd be, Node.js, TypeScript, some AI-friendly front-end library like ShadCN and whatnot, as opposed to when you're working with existing applications. Some of them people started building 5 years ago, 10 years ago. They're using languages like Java. Java, by the way, those developers like to work with different IDEs. They work in JetBrains and whatnot. So there's a lot of that complexity, and right now you can still get a lot of benefit from agents, but you need to know how to wrangle them, if you will, right? So the engineers who get the most value, they oftentimes are very good at writing custom AI instructions, understanding how to run those agents, how to operate those agents. And so part of what we're doing is kind of helping people cross that barrier, right? Doing some of that work for them with our repo grokking stuff, or helping them share the knowledge inside of organizations. Say you're that innovator and early adopter, and you came up with your super cool AI instructions and you build your agent. Can you share that agent with me, so that I don't have to think, I can just click the button and get the same benefits. So that's
and examples of that might be like What kind of examples are you seeing people sharing?
I can give you a real world example from our company. So Coding Agent is doing better job. Our product, right? Let me step back a little bit. Our product, we have software agents, and we deliver them on different what I call surfaces, right? So you can run them here, or you can run them there. Very important surface is developers' IDs, and we support VS Code for Microsoft, and we support the whole family of JetBrains. So those are different platforms, VS Code and JetBrains. And if you run our coding agent on our repository, it will just plain vanilla, it will have better results on VS Code than it will have on JetBrains. And so one of the things that we had to do is we had to figure out, okay, what's breaking, and so how could we make sure that we give the right context to our coding agent and the right instructions, so the code that it produces for JetBrains is still a good code. There's no hallucinations. It uses the right APIs. And then JetBrains is a complicated ecosystem because it's not one ID. They got like a dozen, and there's different versions with sometimes very different APIs, like between 2023 and 2024, 2025. So you got to be very specific in like what sort of APIs you want to use and what sort of architectural patterns you want to use for that code to be compliant with your guidance. So that's an example where ideally you do it once and then you share it with the rest of your team, so they can benefit from it. Another example is again from internal use, but you could see how it applies to everybody. We built as part of our offering, we not only build coding agents, we build testing agents as well. We should talk separately about it. It's a very, very important topic. But anyways, those testing agents, as you know, if you want to write automated tests, there's some setup that needs to happen. So for example, if you're trying to test the billing page, right? Like you need to somehow mock the credit card checks or this or that, because it's you're not going to test it with your real credit card data. So there's got to be some setup that you do in order to make that agent successful. But once you do that setup, it's awesome, right? You write a piece of code and then you call their testing agent, and it creates a bunch of scenarios and scripts for you that you can then put your regression suite or smoke suite or whatnot. So those are examples of how there's kind of institutional knowledge that you need to first package to and share with AI. So it kind of tries to reach your standards of performance. And then once you've done that, ideally you also want to share that with the rest of your organization. So it's not just one person benefiting from that, but everybody else. And then one other interesting thing in that, by the way, brings us to the next generation of products, is what's happening right now is as people are getting better and better doing that in their IDEs, and those agents with human guidance get better and better performing certain simple tasks. We get to the point where you can now trust them in certain scenarios, and that means that you can run them autonomously, which means that there's a need for a different surface, because IDE is obviously dependent on you coming and kind of hitting the button, right? And so one of their most natural surfaces for that is your existing CI/CD process. So every engineering company has their DevOps pipeline, and so in that pipeline, you might have your pre-commit or post-commit hooks and whatnot. And so it's very logical for example, if you developed your own code review agent that does a good job of checking your code against, again, your guidelines, your standards, and if you're happy with its results, then you can easily drop it into your CI/CD, and it will run automatically on every commit. So this is new offering from us, and people love it, and it's exciting. And I feel that that's part of where the future is going, where there's going to be more and more of those agents that run autonomously in your pipeline and otherwise. And what's interesting is that those generations, they're not necessarily fighting with each other. Meaning, you could use coding agents today, and you could still use code completion. And similarly, the third generation, you can use agents in CI/CD, But at the same time, you can still use your coding agents in your IDE to work on the more complex problems, and then you can fall back to code completion if you want to write code by yourself. So those are just kind of again different capabilities, different surfaces, but they're not contradicting each other. And I could see how all three will become continue to stay relevant. It's just that the next generation opens up essentially 10 times more use. For example, if you run in autonomous agents, you can do some things that are harder to do in IDE. So for example, you could blast 5 agents. If you have a more complex problem, you could blast 5 agents, and as long as you can verify their results, you can increase the rate of solving the problem, right? As opposed to kind of typically in IDE, you wouldn't run agent 5 times. It's just a little bit boring and time consuming to do that. So you can do things like that. You can pipeline agents more efficiently. You can run you can script larger kind of migration projects, for example, when you want to run certain pipeline of agents across 10,000 files. So just because it can run in the background, because you can blast many of them at the same time, I feel the aggregate usage there is going to be 10 times more than what we have today in IDEs.
Yeah, that feels like very much like you're getting close to like the kind of Devin promise of like, you just got like a software engineer that it's getting kind of close there. It seems like it's more like directed forms of like autonomy. And maybe the next step is
yes,
like,
and I'm very opinionated just because of how they came to market, and they basically, I think, alienated everybody. Because first of all, they promised stuff that wasn't working, and even today, right? Their agents are slow and they're not best in class. So why would you take something that's slower and at the same time not the best solution? And then also, I don't like the positioning. So I'm not in this business to replace engineers. I'm in this business to help everybody ship more software, right? So part of my passion and motivation is I'm an engineer by training, but I'm a product guy by heart, and I always get a bunch of ideas. And even in my previous business, where at its peak we had about 1,200 people, so several hundred people in R&D department. I think only about 5% of my ideas were ever implemented. There's never enough time, never enough engineers, and so. And big chunk of that work, anybody who worked in corporate or enterprise settings knows that huge chunk of the work is not super creative. And it's sometimes it's not even coding, right? It's just that whole pipeline takes a while. And then when you code, it's not you just working on new features. A lot of it, you're fixing tab debt, you're doing migrations, you're fixing small bugs, implementing these little features, or working on internationalization, working on accessibility, and a lot of other important things, right? Making sure that the solution is secure and scalable and whatnot. So there are a lot of those things and a lot of those checks that are important when you're shipping commercial grade, enterprise grade software. And so I feel that AI could help us take care of a lot of that, so we could move much faster. So that's the goal. And again, going back to Devin, I think the positioning was kind of weird. It's like, as an engineer, why would I spend 4 hours of my day kind of babysitting Devin if I don't get the credit for the PR, right? So I could work in a startup if I'm the owner and the engineer and everybody, right? But in a commercial setting, like you gotta give the credit where it's due, and we're here to help engineers. We're also here to shift left. So I think this is one of the biggest unlocks in the release velocity. So when I talk to VPs of engineers today, again, we're not yet seeing that 2x increased release velocity that AI could deliver. Well, like I think today's AI technology for a lot of companies already could deliver that 2x, even if we don't get the next generation of models, which we will. And the question is why? And I feel part of it is, again, it's not just coding. So very frequent scenario is you code something and then you throw it over the wall to QA, and then, they're working on something else. So it takes them several days to get to it. They check it, and bam, they find some obvious thing that was your job to find, but for whatever reason you didn't. They throw it back to you. You're already working on something else, so you got to wrap that up, get back to this thing, get distracted, fix it. And so all of that accumulates in sort of context switching cost, and more importantly, in the calendar delays. as opposed to you write the code or coding agent writes your code, and then tests are created for you by a different agent, right, and catch some of those more obvious issues. Then it can save a lot of cycles for everybody, and you can kind of stay in the zone, and you could focus on important things, and get the agents can help you do the stuff that you don't like doing as much. And then there's still, I feel there's still important roles for people in all of those stages, because if you, for example, if you're generating more code, right, then architecture becomes more important, and somebody has to think about it. And today, might change with the future generations of model, but today I wouldn't trust hard, complex architectural decisions completely on autopilot to the models. Like, you could use model as a sparring partner, right, as your collaborator. You could sort of ask it to generate some ideas, or ask it to validate some of your ideas, but you got to be making those decisions, right? Or you mentioned QA, right? Like or if there's 10 times more code, 10 times more code needs to be tested. So yes, AI has got to be there, but at the same time, who's going to create the frameworks for the testing, right? Who's going to make sure that it all works well? So there's, I feel the more and more AI can do for us, we actually got more and more sophisticated job that we have to do to kind of orchestrate that AI.
Yeah. That I think that makes sense, and that's a future that I definitely welcome, that we're still going to be of use. One of the questions I really wanted to ask you, and maybe why this is a slightly more technical episode, or like slightly more like in-depth episode in terms of like the actual like technology, is that I think that it's really hard to like not to think about how like developer tools evolve without thinking about how like code, how code is written and how people work and stuff. And so I wondered if you have like kind of any views on, if someone's building, like a feature flagging API, for instance, how they should be thinking about, how this is evolving, how engineers are working, and what it means to kind of build a dev tool.
Great question. So a couple of points. First, let me build off the previous conversation, right? I actually recently had this discussion with my team, which is kind of interesting insight. But as we go deeper and deeper into this rabbit hole, engineers are going to do more testing, and testers are going to do more engineering. It's okay. So because again, testers' job is now going to be more complex. It's not like they're going to have less work. They're going to have work, and that work is going to be more advanced, right? They're going to need to create those frameworks and orchestrate those agents and whatnot. And then engineers, again, if their routine stuff is taken away, then part of their, like, again, there's 10 times more code. They gotta look at what's been generated and then see that it actually what needed to be built, right? So, and of course, there's going to be more architecture work, but that's less controversial, right? Less money. But the fact that, again, the kind of a little bit of cross pollination is an interesting one. Then in terms of again, their evolution of profession, and you brought up the interesting example of building feature flagging API. Again, just interesting bit. If you're working on something that's not core to your business, so it does not add differentiation to your company, does not help you position against competition, I think there's more and more incentives for people to consider open source, not just as consumers of open source, because that's no brainer, right? If there's an open source library that does feature flagging for you, just use it, right? Why would you not? But also to contributing to open source, because if you do that, then the next version of the model, I'm not even saying next generation, just the next drop of the model is going to pick your open source code and your open source documentation, and so you for free are getting there something that's very hard to get. You're getting frontier models trained on your specific piece of code. So I think that and the fact that there's just so much more software written, and there's so many more software companies. Like previously, when I started in SaaS industry, there was less players, and so a lot of the like we were building our own SSO, for example, right, in our SAML. And if I outsourced it, I also knew that my competitor might pick it up, right? And it might have been a differentiator. Like I might have been the first company to ship SSO in my category, as opposed to today. I mean, all B2B SaaS has SSO one way or another, right? So there's no reason to keep it proprietary. Like I assume all good software shop will have feature flagging. So there's more and more incentive to contribute to open source. And as I said, you get in there the free benefit of training frontier models with no GPUs required from you.
I should say the podcast is sponsored by WorkOS. So I think like if people are for single sign-on and SAML, they should just go use WorkOS though, right?
Yeah. No, yes, exactly. Yes. Let's stick to feature flagging, but feature flagging is a simpler component. Well, in my defense, there's SAML and SSO. It was a pretty heavy piece. Like we, in my previous business, like we coded it, we supported it. So the same goes for integrations, right? Well, like everybody used to write their own integration to Google Suite, right, or to SharePoint or whatnot, right? And so like there's no reason to do that. And then
that's an interesting point though. I think also maybe like the internals, like I guess like because every dev tool, whether they're open source or not, their documentation is going to be like open source. They're gonna put that out there a lot, but maybe once these things get really advanced, the fact they know how the actual insight, not just the surface area of the API, but like they can see the raw code, like they know how it works. It might be like, be able to like preempt why things are not working and stuff like that. It'll be like,
or just give
really
me an interesting idea. So it could be, it doesn't exist today, right? But what if you could publish your internal API docs to LLMs, but in a way that would not get them picked up by Google, right? Because right now they obviously work off the same index. And so if you do that, you're kind of exposing your internal APIs again to your competitors, which could learn from that. But what if you could expose it to LLMs without it being indexed by Google? But it's interesting. I also think is the deeper we go into AI world, the more just the rare speed is an advantage, as opposed to kind of, hey, here's how I've done things, or like I've implemented it 6 months ago. Well, guess what? And say 6 months in the AI age is a lot of time. So and if the competitor learns from what you built 6 months ago, maybe that's a good thing for you because you're already building it in a very different way today, right? So I think there's less and less of that proprietariness and more value in just speed, understanding of your customers, understanding of the market, understanding how to build with AI into your product offering and how to leverage agents into whatever you're offering to your customers. And again, less and less in the proprietor. And then going back to your kind of question about evolution of profession, one other interesting kind of funny, semi-controversial insight is if you for like I noticed that people hire senior engineers, right, and they do it for the reason those engineers are very skilled, experienced, and have bring a lot of value to the table. And then those engineers sometimes try AI agents, and agent fails, and that engineer does what he's paid to do. He comes and manually solves the problem. Awesome. And then you compare it with a vibe coder who does not have that experience, might not even know the programming language. And when AI agent fails, good vibe coder with the technical chops and engineering mindset, he will try to solve it with AI agents. So he will write some AI instructions, play with them or whatever. And so if you fast forward that like a week or 2 weeks, right, the senior engineer will have the same level of AI capabilities, and the vibe coder will have much more advanced harness and tooling and prompts and whatever. And so he will actually be a better AI engineer, if you will, and engineer in the true sense of the word, which I respect, like somebody who creates, builds, and somebody who, whenever you create and build, you always face problems, and engineer is the person who solves the problem, right? So from that perspective, that vibe coder again could do something that That's amazing. And I've seen this also work with senior engineers as well. For example, one of their in one of the companies, they're working on a very large migration, and they absolutely have not enough humans to manage that migration. So they cannot do it manually. Well, like there's a constraint, right? And as you know, constraints breed ingenuity, and so all they can do is work on prompts for agents to make sure that the agents can do that. And again, they have one of the most interesting and sophisticated setups that I ever saw, was kind of like hierarchical prompt templates and whatnot, and that pick up from environment variables, and there's a workflow on top of that as well with multiple different agents, and then there's like execution of that workflow. So that's something for senior engineers to think about if they want to stay competitive in this market, and if they have that internal drive to be able to build faster and better and be the best in the area. Well, like maybe sometimes they need to create those artificial constraints and try to do something without using their prior knowledge. And then they're unstoppable, because then they get the best of both worlds, right? That they get their AI chops and they get their like 10 years of experience and context and whatnot.
Wow. Star vibe coding. That's what I'm taking away. Amazing, Andrew. That was really, really awesome. If people want to learn more about Zencoder, where should they go?
Zencoder.ai.
Awesome. Are you any shout outs to make, any plugs?
Sorry, that is an awkward pause that probably better cut out. But
No, maybe we should just keep it because it's more fun now.
Yeah.
But you're not here to plug. You didn't have the plug instantly ready to go, so it's more interesting to hear.
It's exciting space. I think all engineers should be playing with coding agents today. They don't know it yet, but I think they also should be playing with testing agents. So would love them to try our end-to-end testing capabilities. And then I think it's also a good time for the ones who want to stay ahead of the curve to start playing with drop-in agents in CI/CD and figuring out good use for that. And then for everybody, I think it's time to broaden the perspective from coding to software development lifecycle, right? So it is a process, and again, unless you're solo vibe coder, if you're working in real organization on a corporate enterprise level, it's a process, multiple different steps, multiple different tools, sometimes multiple different teams, and a lot of time could be saved kind of in optimizing things across the process rather than just coding. But coding is the most fun part, and kind of that sits at the core of it.
Amazing. Also, thank you very much to Amy from Anthropic for making this episode happen, and that it's coinciding with the launch of their enterprise. Well, Andrew, maybe you can share what it is because you're part of it.
Yeah, they're launching the enterprise partner directory, which is exciting, and it comes on the heels of their recent Claude 4 launch, which is amazing set of models. Sonnet is a good kind of workhorse for daily tasks, especially in software engineering. And then Opuses are kind of a bigger thinker model. And I like using both, and I also personally use their research mode quite often for different kind of executive assistant type tasks that I don't have time to do myself.
Yeah, I actually used it for making this like prompt for, I was trying to do some stuff with 11 Labs, the voice stuff, and it generated this amazing prompt that like went and researched lots of people, and it was really good.
Yeah, but by the way, if any of your listeners are not doing it yet, that's one of their best things to do. Like if you're facing a complex problem and AI isn't working really well for you, try using AI to help you generate more extensive prompt, and you can kind of guide it, say, hey, here's what I'm trying to accomplish, here's where I'm failing. Could you help me generate this mega prompt that will alleviate this issue in the future? And especially if you give it access to some tools, for example, I've recently done it with a piece of our code, and I give an agent access to code files, so it could extract valuable information. But you could, of course, use different tools, different connections. Like if you're working on emails, you could probably give it an RCP to access your Gmail or something, right? If you're working on calendar, give it access to calendar and kind of guide it, and it can look up the past information, pick up some patterns, and create a good prompt that you can then copy paste or create Zen agents and reuse in the future.
Yeah, that's a great tip. And also, I love the phrase mega prompts, by the way. I feel like that should be common parlance. Okay, well, that's it. We'll say a second goodbye. Thanks everyone for listening.
Thank you.
Thanks, Andrew.
Thanks for hosting me, Jack.